So sometimes in Algebra 1, you have to be quick enough to recognize that some problems do not have solutions. We are in lesson 410, and sometimes problems won't have a solution. Can't solve them. Our essential question is, can you recognize problems that do not have solutions? Says, not all work problems have solutions. Here are some reasons for this. Number one, there's not enough information given. Number two, the given facts lead to an unrealistic result. What is an unrealistic result? Well, I have -5 people. That's not very realistic. I have a negative distance. Again, not realistic. And then number three, the given facts are contradictory. So we want to look at a couple. Well, we'll probably start with one. For the senior play, twice as many adult tickets as student tickets were sold. If $420 was collected, how many student tickets were sold? Well, even if I built a chart, which I'm going to make a mini chart, we know that the number of tickets times the dollar amount of tickets is equal to the total. We know we have adult and student tickets, and the total column is always what we'll work with to solve the problem. But it says for the senior play, twice as many adult tickets as student tickets were sold. So if I call student tickets N, I would call adult tickets 2N. Well, because they tell us a dollar amount, but they don't tell us the information for the dollars for the adult tickets or the student tickets, in this case, there was not enough information given. So we are unable to solve this one. All right, moving on to the next one, example 4. We are right here on example 4. And it says a pool with an area of 196 meters squared. Well, let's draw our pool. We just did this in 4-8. Here is my pool. And we know that the area, oops, probably should leave some room for the area, is 196 meters squared. That's the rest of my pool. And it's surrounded by a deck 1.5 meters wide. So I know that this from here to here is 1.5. From here to here is 1.5. Find the area of the deck. Well, remember for all of these problems, we had some kind of width and they compared it to some type of length. In this case, we don't have any width and length comparisons, so we have nothing to add the 1.5 this way and 1.5 that way. So in this case, again, not enough information was given. All right, last one. I'm moving up to example 3. I'm going backwards. One number is 12 more than 3 times a second number. So let's call the numbers 1 and the numbers 2. If I call the first number N, I can call the second number 3N plus 12 because it was 12 more than 3 times the second number. I actually have my first and second numbers mixed up, so let's go ahead and switch this one to the second number and this one the first. Find the numbers if their sum is 4 times the smaller number. Well, I know that this one right here is the smaller number, so we need to take that smaller number and multiply it by 4. And then it says the sum. So I have to add these numbers together, which you guys are rock stars about just adding down. So I know that 4N plus 12. Well, remember what happens if I have a 4N on one side and 1 on the other. If I cancel that out, that means 0. And in this case, I have no solution, which can work with algebra, but it can't work with a word problem. So the given facts are contradictory, so we don't really know the solution, and no solution would be a proper answer for this.